So let's get started. There's just a random list of languages I guess everybody hates, or like I bet there's at least one language on here everybody hates, but we are still missing something. So if we look at the numbers, if we hate by numbers, we have like C++ with like maybe 5 million users by now. C has 2 depending on the sources you get. Java has 9 million, and JavaScript 10 million, and we all hate JavaScript, right? So, and these are somewhat old numbers, and I'm not really sure how reliable the sources are anyway, but still, this, like, who cares? Like, who cares about 10 million people using a language? If you have, like, really big ones still missing, and, like, these are all small fish compared to Excel. Like, official Microsoft number says, like, 750 million people using Excel. Like, who cares about C++ or JavaScript anymore? Like, come on, people. But I know what you're thinking. Excel is not real programming, right? Like, come on, Excel. It's like cells and you click and stuff. But Excel is functional programming all the way down. Like, you can do everything. It's Turing complete. I've seen graphics engines in Excel, like using Excel cells to actually show the pixels. What else? What do you want, right? So let's bash a little bit on spreadsheets. And I have to be clear here. I'm not bashing Excel or Microsoft. I mean, if you think about it, numerics is a re-implementation of Excel. And my argument sort of would go that Excel in itself is not the greatest thing. Why would you re-implement it? And LibreOffice, Google Spreadsheets, pretty much all the same. So if any Microsoft people are here, please don't feel offended. I'm offending everybody. So the first thing that's really bad is you can't see the code. You have to click on the cell and then look into a small window and see there are some calculations going on. So far, so bad. We have dynamic typing, like the best. We have all the best features. You have like a first name, which is a string, a last name, which is a string, and an age, which should be at least an integer. Come on, people. We have an integer and a string. Well, there you go. Like, your calculation is broken. But you can sort of do it even better. Now you have 2 numbers, right? Well, wrong. The second one is a string as well. See, now it's going to be interesting. Whoa. See the small tick there? That makes it a string, even though it writes 22. So, well, your loss. And where were we? And now the clicker is broken. Awesome. Come on. Yeah. That joke did not fire well. Git blame on spreadsheets. Google Spreadsheets have a little bit of versioning, but not that much. I mean, let's just not go there. Spreadsheets on shared drive, that's like the beginning of all evil. It even gets better. So if you write this small formula into your cell, what do you expect? You expect to get an equal sign identifier, a left parent, an integer, a comma, an integer, and a right parent, right? That's what you expect. Reasonable people would expect this. If you set the locale inside of Excel to German, for instance, give it the same formula, you get something different. You get an equal, you get an identifier, you get an L parent, and then you get a float. What the, right? I mean, who cares about named values or R values? I want this and D. That's like, and there are, like, I could talk for hours about this, but just to wrap up, you have knowledge silos. Like, how many companies went under because the one employee who understood the spreadsheet, actually had it on his machine, left the company and took his laptop with him. Like, the knowledge is lost. There's sort of no inbuilt mechanisms or idea or process to share your data. It is goddamn slow. Like, if you think Ruby is slow, try Excel. Like, that's really slow. Your code, your data, and your presentation, it's all in the same place. Like, the first thing you learn when you learn programming, separate your code from your data. Not in Excel, you don't. And access management, that's like, what? Doesn't work. Like, either you see it or you don't. There's no in between. Like, you can't see the formula and the data, or you can't see the data or the formula. You have nothing. And like, how does sort of the usual Excel workflow go? So you create your own small spreadsheet to work, like to do your shopping list. Then you show that to a colleague. then suddenly the whole company is using that spreadsheet to do all these purposes. Then you build a web front end on top of that because it's sort of convenient and it works. And suddenly your company is an e-commerce company and your database is an Excel spreadsheet. And it's like, okay, now we have a problem. And like, people do this kind of things. Just sort of a few examples. Excel now will cost the company 24 million. You say, oh, 24 million, okay, that's bad, but that's not really bad. There's sort of the so-called London whale, and if you can hardly see it here, due to some mistakes in Excel, they lost 6.2 billion pounds. I mean, that will sort of kill most companies. Like and like it goes on and on and on and on and on and on. And this one, the last one, is actually quite funny and tragic in sort of both ways. In Idaho, the Medicare provider was like they used Excel to calculate how much people got sort of on benefits. And of course, the algorithm they used was proprietary. And a couple of people complained because they got sort of half the money the next month they got the month before. And so the company had to release the Excel spreadsheet, and everybody was sort of buffed that it was an Excel spreadsheet that actually did the calculations. And of course, the Excel spreadsheet had mistakes in them. And pretty much the judge ruled this Excel spreadsheet to be unconstitutional in Idaho. I mean, unconstitutional programs, we are getting somewhere. And there's even sort of a collection of people, they were so upset with Excel that they created a group that investigates the risks into Excel. Like,
this program has performed an illegal operation and will be closed.
Exactly. It's like, what? And sort of Excel rules the world. What do you think your governments are using to do their modeling and forecasting? Excel. What do you think pretty much all the companies do to do their work? They use Excel and spreadsheets. And to quote Andre here, I'm not kidding. That's like, really, like Excel is everywhere and you can't escape it. And you really should feel like this right now. It's like, like JavaScript is like Wonderland against that. So before we move on, there's sort of two assumptions I'm making that you all have to sort of agree with, because otherwise the rest of the talk is somewhat pointless. So first is, you actually believe me that spreadsheets rule the world, even though you hopefully don't want that to be true, but it is just true, at least in my opinion. And the other thing is, I hope that you want D to rule the world instead, because let's be honest, D has made a lot saner choices over the past 10, 15 years than Excel has, over the last 35 years. I mean, we still have some time to do some bad decisions, but I think so far we are on a good way. So how are we going to win this? Well, bad news, we are not going to win this because Excel has 750 million users. There's no way we're going to win this. But there's sort of things we can do, so let's start. So what do we have? Way too many spreadsheets, way too many tasks, and I think everybody here in the room is like really busy all the time and is doing his sort of best to keep his head over the water. And of course, we are way too few people to actually do all this work, to sort of push Excel out. I mean, even if we sort of have 10 times the people in this room than we had right now, we still wouldn't be like nearly enough to do anything. But the cool thing is, we have millions of lines of programs in different programs, and we have D. And sort of D is our superpower, so to speak. So with D and all the code that is out there, and the ease in which we can tap into that code from D, we can do a lot. So there's one possible attack vector. If you're the CTO of a company, just disallow Excel everywhere and then go directly to profit. Or have everybody leave the company because they still want to use Excel and don't know anything else and think D is just a joke. And if you're not a CTO, you might be just able to get everybody using Excel to be using Excel in a way that they have one table per worksheet. So I don't know if you know, but you can have multiple sheets in one Excel file. And if you have one table in one sheet, exporting that to CSV is actually not that difficult. And if you have the data in CSV, going from there to something more sane, say a struct in D, is actually not that difficult. And So you sort of make the life for the people you're working with and those people working with Excel not too inconvenient. And by that way, your life is getting a lot more convenient, because if you have it in CSV, going sort of the real programming route is quite easy. So, but that is not sort of the main problem we have. We are, as said earlier, we're way too few people, and we just don't have the manpower to do everything. So the first thing that will pretty much come up is people ask you, but I need this data in a spreadsheet. And you're like, oh my God, I just told you spreadsheets are bad, for the lack of a better word. And so what can we do? But they still insist. The data has to be in Excel. That's what we send to the other company that is supplying us with whatever. So the data has to end up in Excel in one way or the other. And to be fair, looking at tables in Excel is for most people a lot nicer than looking at tables printed out to the command line. It's just true. So what can you do? Writing something that is actually able to put out Excel spreadsheets in a correct way and actually adheres to the standard and does all the formatting correctly is like a huge task. Like, there are sort of rumors that even the people developing Excel look at the source code and documentation of LibreOffice to understand their own format. I mean, this rumor might be true or not, but if that somebody thought up this rumor sort of tells you a lot about the standard. Luckily, though, there is this library that already does pretty much everything that you want. But wrapping that by hand is just too much work in itself again. Because even though it's an IC library and it's very good documented, it's just, the amount of work is just too much. You have like 78,000 lines of C and macros and enums and everything. You can't, like, you could do this by hand and write all the X and C statements, but you really don't want to do that because it's just tedious and you have better things to do, right? So DPP to the rescue. Just put the headers in, run DPP, and you get out like 4,000 plus lines of somewhat nice D. The problem, though, is it's still a C interface. So you basically have this. You can call it, and everything works, but actually using that is just too tedious, and you're typing and typing and typing because C has no function overloading, and of course DPP is doing its job proper and just translating and not doing anything else. But as you can basically see is, this library is good old C-style object-oriented programming. The first parameter is the this pointer, this is the namespace, and that is the actual function call. So taking this and translating this into that's like half a day's work, right? You write a couple of scripts, use your favorite editor to do most of the typing, and you're done. You just call the thing inside, have the this pointer there, have a struct, and move on with your life. And that's what we did. So now we have an Excel writer that is pretty feature complete, and it took like maybe a week to build completely, and it works. Perfect. We can move on now. So another problem that came up recently is we had to create fake user data to test our system, to test the displaying of information and so on and so forth. And we wanted a lot of attributes. We wanted name, address. It should have worked for like different locales, stuff like that. And to be honest, the situation was like this. We have but you actually want JavaScript. Like, if you go into the D standard library and look at std random, it's awesome. You can shuffle things, you can select things, you get random numbers, but addresses, not so much. Dub, like code.dlang.org, didn't have anything as well. So looking to JavaScript, I had to do some JavaScript some time ago, and the JavaScript creation was awesome. So I looked at my favorite fake data generation library in JavaScript called Faker.js. They have like 160 attributes and locales for like, I think it's 40 by now, 40 languages, and everything is there. Like the most obscure attributes you ever wanted, they have fake data generation for that. Luckily, JavaScript is a somewhat simple language. And most files that generated the actual fake data were made out of this. So This is basically their inbuilt template language they use. So you replace this part with the first name, have a space, and replace it with the last name. And turning this into this is like a day's work, right? So you take all the attributes and turn it into this, and turn it into function calls. Overload it on a class and do it for the language. And then you had to do some JSON parsing inside as well, but come on, we have a JSON parser, and you're done. And it works. Period. You have sort of created a whole library in a matter of hours even, and you can just use it. And sort of the usage is as simple as you can imagine. You create a new instance of your faker, give it a random seed, and then get a name. Perfect, done. Sort of the work that I had to do was, like the parser and the generator is like 1,500 lines of D, and then there are some parts which couldn't in any reasonable amount of time be parsed by the generator and then regenerated. I mean, there are some JavaScript functions inside which just didn't make any sense to try to translate them automatically. So I did this by hand, and the JavaScript was reasonable. To be fair, most of that could be like partially translated by Vim macros, so that's what I did. And the output was like 70,000 lines of a Faker.js clone that is just working. And actually, if they update their thing because they have introduced new names into the database of names they have, or if they introduce a new language because suddenly they sort of have somebody else that did a translation, we just have to rerun the tool and put a new tag on the Git, and we're done. And the most awesome part about it is I actually was able to find a couple of bugs in the library because the template extension, of course, is not checking if the names are there at compile time, but my thing was checking if the names were there by compile time, and some of them weren't. So I was sort of gloating and putting up a couple of pull requests for them to fix the library, and that was the best part about it, right? But still, I mean, we are able to create Excel spreadsheets now. That's pretty good. And we are able to create fake data. But we're still not hitting hard enough. I mean, let's say we are 75 people, and there are only 75 D programs in the world, even though that's not true. But let's assume that for a simple math example here. And there are 750 million Excel programmers. That means, like, every one of us has to be as good as 10 million Excel programmers. So with the techniques I just showed you, we maybe get up to 1 million. But there's still a 10x there. So one of the things that also had to be done is you wanted to have a table in the web browser that showed you the first and the last name, and then sort of a salary and by whom it was created. And from that, you sort of derive a somewhat sane class hierarchy. You have an employee that has an info, and the info has a salary, and the salary has a currency amount, and the currency amount has a currency and its value. And that's sort of the same thing you do, and you can easily put that into a database, like creating your own sort of small library that talks to Postgres or to MySQL or just use something from DAP. That's like a thing of 10 minutes. And then you create this nice interface that you can easily do with VibeD, and you get your simple REST interface where you can get all employees, where you can get a single employee, and then get the employee info and stuff like that. All nice and dandy. On the front-end side, JavaScript now is somewhat replaced with TypeScript, or at least sort of everything that comes out new, or where every new development is starting. TypeScript is the quasi-standard, I would say, but now. And they actually have types. I mean, the name TypeScript sort of implies they have types. So translating these structs or D classes into TypeScript interfaces or classes is trivial. I mean, everybody here in this room can read this right now without ever having seen TypeScript. Like, the only interesting part is the question mark there, and that basically just says it's nullable. So you know TypeScript now, or at least enough for the presentation. And also, if you have the REST interfaces on the D side, generating the interfaces on the TypeScript side that allow you to have a simple function call that is then actually doing the HTTP request and getting the data back and putting them into the interfaces so that you can actually reason about the JSON or the JavaScript object you have in front of you is also trivial. I mean, if you know the endpoint and you know which HTTP library you're using, generating this, it's like, okay, I'm going to do this in 2 days now. And then it's going to be done, and it's going to be awesome. But still, the problem lies, you have to, at some point, join up the individual endpoints into one JSON object and display that, or use that then to actually drive the generation of the HTML. And there's a question, yeah?
I think you can also directly generate the front-end code in Byte-D.
Yes, Byte-D has a JavaScript exporter for...
Yes, a JavaScript exporter, but not a TypeScript exporter. And yeah, and then, but you still have to have, like, yes, and then you just have to do a typecast in JavaScript or TypeScript to the real type. And yes, works, but like doing this was sort of, oh, okay, I'm just going to do that and done. Anyway, so at some point you want to assemble the TypeScript classes again together to give it to the HTML layouting engine. And this is the most sane approach I found on the web. And this is sort of what RJS do, sort of the observable schema of what TypeScript introduced. So you have the backend, you get all employees, you pipe that to a merge map, which basically means from that point on, it can sort of create multiple calls to the backend, and all those are going to be collected and returned as an array of employees again. So in that, you basically loop over all your employees you got, and for each of them, you do another call to the backend and get the employee info, and then you repeat until you have finally the salary for all the employees, like for all the currency amounts, and so on and so forth and so forth. And as you can see, the code is going on for quite a bit of while there, and there's just like, why? Why do I have to type this? Annoying. And what is even worth about this is the amount of network calls you have to do. So you start out like somewhat innocent, you get to the backend, get all the employees, but then for all the employees, you're going to fetch the employee info, which is like 1n, and then for all the employee infos, you get the salary as another n, and another, and another, and another, and suddenly you have the data. Of course, you could go the route and say, I'm going to create one REST endpoint where I'm going to fetch all this data. But then, in the end of the day, you will have like 1 million REST endpoints, all with sort of niche implementation or niche differences to get specific parts of the data that's required for the view you're actually trying to display there. And that basically just doesn't scale, at least not if we are 75 programmers and have to be productive as 10 million programmers. Like, I think you can all believe me that. So that is clearly unworkable, and it's not plastic at all. I mean, this code is not that difficult to write if you've sort of understood what merge map and the pipe operator do. But still, it's like too much work and like too many lines. And also, it's just boring. I mean, I think sometimes we underestimate this factor. If it's boring, you're sort of not going to pay 100% of attention, or 100% of your attention, and you're going to make mistakes. And then you have to do it again, and it's even more boring the second time. So the real takeaway is like, you're going to sit there like this, and you're just not going to get there. It's like, it's just not going to work. So what do we, or let's say I actually want? I want to declare how I want the data to look, and I want to get the data in that way and then just display it. I don't want to really do anything. I just want to say, this is how I want it, please give it to me. So why can't I write this? I mean, everybody can read this, right? You get all employees, for all employees, you get the info, the first name, the last name, you get the salary, the amount, the currency, the name of the currency, and you get a created by, which gives you an employee, the info, and the first name and the last name. And how do you want that data to be returned to you? You want some JSON, because JSON, let's face it, is the language of the internet. Like, if you can talk JSON, you can talk to the internet. And you basically want that. And if you look at that, sort of add a colon and then some data, this is basically JSON just with the keys, and there you have the values attached to that. Good so far? And people actually did this, GraphQL. So some time ago, the Facebook people had basically the same problem, and they invented GraphQL. And basically with GraphQL, you can write that query, give it to a backend that understands GraphQL, and get that JSON back. Done. Awesome. But GraphQL, of course, because it's a JavaScript library, had to invent their own type system. So they did this. Yeah, I know, but it's not actually that bad. So I think if you can read D and you can read TypeScript as I just taught you, you can read this, right? You have a type which has a name, it has sort of an identifier and has a type associated with that. But here, the difference, the ampersand means it's not nullable. So in TypeScript, you have to say if something is nullable. Here, you have to say if something is not nullable. Go figure. But still, yeah, you live and learn. So then the cool thing is you can actually sort of do a little bit of programming with GraphQL as well. So let's say we have this one query, and we want to get all employees, and then we have the ... deep. And the ... deep is basically a macro, but they just don't call it that. They call it a fragment because macro is sort of a bad word. So it's called fragment. And basically what this does is it copies that text there. So it is a macro after all. And you can, of course, have nested macros, but you just don't, you're not allowed to have circles in those macros. But still, you can sort of reuse your fragments to make your typing, like you can reduce your typing by using fragments, basically extending or building up your tree of what data you want in such a way. And you can even introspect the type. So this is the cool part. If you have no idea about what the endpoint can give you, as long as you know its URL, you can figure out what the endpoint can give you. So for instance, you can say this. Maybe you know there's an employee type in the endpoint. You can ask for that type, __ type, then you can get the name, and then you can get the fields. The fields are basically the members, because everything has to be renamed somewhere or the other. So fields is what they call members. And then you can ask for the name, which is in this case the ID. And if you ask then for the type of the field, you see that is what kind it is. It is a non-nullable, and that is of type int. So you can actually introspect the whole endpoint. And you can also attach documentation to the individual fields and types. So you don't have to know the place where the REST documentation is saved, on which drive in your network, or you don't have to regenerate anything. As long as the endpoint is up and running, you can introspect the whole type system. And you can also introspect that to an arbitrary level. So even though everything I showed here was only trees, you can actually have graphs. So the employee info has a created by attribute, which is in itself an employee. And with that on employee, you can get to the employee info, and from that you can go back to the employee. So you can have arbitrarily deep nested trees. And you can actually introspect that. I mean, at some point it becomes silly if you go sort of 10 levels deep. The JSON you're going to get back is going to be a couple of megabytes big, but still, you can do that. And actually, there are front ends to GraphQL endpoints where you have type ahead. How do they do that? They introspect the endpoint in the beginning when they start up, and then they have all the data they need to do type ahead. Pretty neat. Unfortunately, I found this situation. No entries for GraphQL on DAP. Well, and I had this one on my shoulder. I was like, I just want that. I want to build the tool that makes me or allows me to write less code. It's just like, just have to do it. So, well, that's what I did, right? It starts pretty innocent. You define an interface for your query entry point there, and you just say, get all employees, and you just return your class, the destruct I showed earlier. You just return that and an array of that. And sort of the top level entry point to your schema is your schema. And your schema has a query type of type query, and by this way you sort of have an entry to your GraphQL endpoint. And then you have to provide what they call resolvers. Basically saying, if you're asking for this type and this field on this type, call this delegate, and that then should return something that is equivalent to the type that you specified. And here, you get sort of passed in a couple of things. So first off, you get passed in the name, because for whatever reason, you sometimes create delegates that don't know their own sort of purpose, but you get the passed in the name. You get passed in the parent, and this sort of is the interesting part. So where's a good example? If you have the employee info and you want to get the salary for that employee info, you have to have some association between the info and the salary. And usually this is done by an ID. So you have in your salary table, you know that this salary is associated with that employee info with that specific ID. But how do you get that sort of into the resolver? And the idea there is that the parent object that was just resolved gets passed into the current resolver. That's what the parent thing is. And the third part, the args, is you can also provide arguments to the fields you're trying to resolve. So instead of getting all the employees, if you're just trying to get one, you have to pass in the ID of that employee that you actually want. And those will end up in the args JSON object. And the last thing, the context, is just a thing you can define that holds, for instance, the authentication info or the connections to your database or the thing that logs for you or whatever. That's sort of the last thing that you can define to pass in additional information to your resolver. And then it's pretty simple. You go to your model and say, get me all the employees, and you create a new JSON object, and you serialize your data into JSON, and you return it. And if you do this for all the endpoints, for most of the aggregate types in your schema, you're done. Actually, for like primitive scalar values like integers and so on and so forth, there's a default resolver that just looks into the parent JSON and says, the ID is already in there, just return that. But if you sort of do nested things, you have to provide your own resolvers. And if you have done that, every imaginable endpoint or query to your system is done. You don't have to write anything else. If, for instance, you don't want the first name in the query, just remove first name from the query, and it's not going to show up. If you want also to have its middle name, and there's a middle name field, just insert the middle name. And you have a new specific endpoint to your needs. And if you want to go like query your whole database and go 15 levels deep in your tree, please do that. But then make yourself a coffee and wait for 10 minutes for the data return. But still, you can do that. Everything is done with when you have implemented your resolvers. You're done. Like the last bit of scaffolding you have to do is you just have to create your vibd endpoint. We basically extract the query, do some validations on that, because we have a type system and we have the query and we actually know how the model is looking. We can do some validations. So for instance, if you're trying to query the cat name on the employee info, and you know there's no such field as a cat name on the employee info, you can reject the query right there, because you can't query for something that's not there, right? And just sort of validate your query a little, and then execute the query down there on line 14, and write that back with like normal vibd JSON generation, and you're done. So this is, for instance, the resolver for the employee info. We have a field called info on the employee, and we know that the parent is also populating the field info ID. And we get that out of the JSON, convert that to a long, and then use that long to get the employee info from the database, which is just abstracted in the call to get employee info. And you can sort of see the schema behind this. Pretty much all the resolvers you write will look one way or the other, pretty much like this. It's like, and actually, much of that can actually be removed. If you sort of do another layer of indirection, just say You create a like template delegate where you say, I need this field with this ID, and if you have those values, then you call that function. You can delete most of that code as well. And the amount of code you actually have to write is very limited. So right now, GraphQL can be used. Just include that in your .json. It's mostly feature complete. There's like one last thing I have to do. I just didn't get around to it yet, and it's actually not that interesting and not that widely used. But I'm probably going to do it like today or tomorrow, depending on my schedule. And some of the validations are missing. They have somewhat obscure validations in there, and those validations are not that critical to the system that is executing the query. But most of them are already done. I just sort of have to find time as well to do that. And the implementation itself is actually quite limited. So there are 17,000 lines in them. And 9,000 of them are generated by a small parser or a parser generator I created, Darzer, which is also generating the AST and most of the visitor patterns as well. So like 8,000 lines and change for GraphQL implementation. And yeah, just go and use it. It's awesome. You're never going to want to use REST again. Period. So I think I'm a little bit fast, but nonetheless, we're sort of approaching the end. And as I'm coming from academia, there's going to be a homework. So we're going to combine the two, right? Your homework is to write a nice GraphQL backend to an Excel spreadsheet. It sounds bad, it really is, but the endpoint you create is going to be nice. You have everything you need. You can, so the type system inside of GraphQL is technically fixed, and you can generate that from your classes that you use for the backend. But you can also create them in code, because that's basically what I did. I wrote an introspection system that is then creating the classes that represent the type system in memory. Because the introspection thing is all auto-generated. You don't have to do anything, but you can do it manually. So what you can do is take an Excel spreadsheet, hope that somebody in the first row put the names of the columns, because that's something reasonable to do. And from that, you can generate the type of the worksheet you're looking at. And then you can create your GraphQL endpoint that returns those individual rows or all of them. And you can also create a mutation for the GraphQL endpoint, which then adds a new line to the Excel worksheet, because you have a way of writing Excel worksheets and workbooks. So you're pretty much done. Like the techniques or the tools are all there, you just have to do it. The only recommendation I have is don't use that in production. It's not going to be good. Use a real database, but I think you get the point, right? So what do we learn? Spreadsheets are a terrible language. You just don't want to use that. And sort of, I think the more important part, I think everybody knows that spreadsheets are bad, but I hope the important part is that people recognize that C++ and Rust are not our main competition. Like if we go by numbers, we have to, like if we get 10% of the Excel users, like who cares about JavaScript, Rust, or C++? Like those are all niche languages then. Like, and sort of how do we get there? We need to learn to use what is there. Old JavaScript is terrible, but new JavaScript, like ES7 and 8, actually is not that bad. And if you have TypeScript, translating TypeScript to D, like it's not that hard. And we have like millions of lines of Python. Why are we not tapping into that? Like it just doesn't make any sense. Like why are we re-implementing all that stuff? Because like most of the stuff there works, is fast enough for the applications or for the things we needed to do. We have to tap into that. We can't re-implement everything. We're just 75 people here, right? And we have to be 10 million times more productive. Just doesn't scale. And how do we do that? We need to write the code that writes the code. Like, generate everything you can generate. If you have to do it twice manually, you're already losing the battle. And to be frank, I think I'm going to sort of get beaten up for this, but look at JavaScript for inspiration. They have some crazy good libraries there. Like, why don't we have a React library? Like, Angular is awesome. It's like, it's shit, but it's awesome. Like,
It's awesome shit.
exactly. Like, it does the job. It scales. You can scale your teams on it. It works. TypeScript is awesome there. And yeah, like all those JavaScript script kiddies, like every once in a while they have a very good idea. And there are so many that they have many good ideas. So yeah, and then sort of to close up, GraphQL. Like, it's really awesome. And because I'm so fast, I can actually go to the encore. So these are the references. The slides are up, I think, already. So nobody cares about them anyway. So there's sort of a couple of patterns that reappear, sort of that I found that reappeared. So we have user-defined attributes. Those are awesome. But if you have sort of a list of 10 user-defined attributes on a single value, it sort of gets tedious to query for those in your introspection part, right? Eventually, you want to have all the values associated with your library and that UDA in one place. So here, for instance, we have, or the GraphQL library has a UDA called GQLD, which is GraphQLD, right? And you can associate descriptions with fields and also deprecations and the reasons for the deprecation. So GraphQL actually has an inbuilt deprecation process in the language, similar to us. And like I've never seen a GraphQL endpoint or a field that was deprecated, but nonetheless, the technology is already there. But sometimes a field is not deprecated, right? And you don't want to you don't want to type everything. So you don't want to retype the @ and the GraphQLD prefix and whatever. You just want to say this and have the description and the deprecation associated with the number. And their implementation is like, there's just a tiny trick to it. So the deprecation is either undefined, no or yes, and the description is just a string. And at the end, you basically want to have a struct called the GraphQL data that has a description and a deprecation. And you want to use that, and you don't want to do anything else with it. You don't want to query for the description or the deprecation individually. It doesn't just scale. Annoying, you will forget stuff, bad. So the pattern I found is you create like a template function that takes whatever, and then you iterate over all the members of the GraphQL data, check if any of the arguments you pass in are of the same type as the fields in your GraphQL data, and if they do, you assign them. Sort of the only caveat there is that you can only have one type appear once in your class or in your GraphQL, in this case, the GraphQL data thing. But now you're done. If you're adding another description 2 for the lack of a better name or something, or don't know, anything else to it, you're done. This function takes care of it. And that's what we have to do. We have to write code that writes the code for us. And this is doing that. Like, you're done now. And whenever you have the GraphQL data, you can be sure that if you passed in those things to a field, they will appear in your data. Done. Awesome win. Like if you look at the implementations of GraphQL in JavaScript and C# and Go, it's terrible. The amount of work they have to do to get this data out and actually associated with it. It's like, oh my God. Like, and I know I looked at those to sort of get inspiration on how to implement the one in D, and it's just not fun, just no fun. And another one, Andre talked about this yesterday. Static for each in a switch casement. It's like, one day at work I was sitting there and, does this work actually? And I was typing and it worked, and I went over to John and I was like, look what I found. And he said, yeah, we're doing this all over the place. Like, why is nobody talking about this? Like, basically inside the introspection of the GraphQL types, you have JSON and you want to get the associated D type to the JSON. So what you do is you extract the name out of the JSON, and that somehow ends up in the type name string here. And then you do a switch on that type name, and you have a magic function that for this is going to be your schema, the T here, collects all the types in your schema Oh, I'm running out of time. Good. And because I'm running out of slide as well. So you collect all the types. Whoops, that was too fast. Wrong direction. You collect all the types in your schema, and we're going to get to that baby in a little. And you do a static for each over all the types. And if the type name matches the string you passed in, you just do sort of call a magic function type to JSON and populate that. Yeah, there's a question.
Very widely is because it can be very, very slow. If your type list is very large, that thing will explode in your face.
Yeah, there's actually like 2 slides down with the exploding part. But still, this is like a huge amount of savings. Like the amount of type, like the amount of code I was able to delete when I found this was like, oh my God, I'm just deleting code and it still works. Awesome. So another cool thing, collecting the types of the system is possible but tedious. That is sort of usually the code you find. You check if you have don't know, an aggregation or is custom type or a union, and then use the different functions to introspect that to get to all the underlying types and the member fields and so on and so forth. But this gets tedious fast, and the if-else, and you just can't put it on the screen anymore, can't read it. And actually what you can do is sort of a ternary type expression. So you get, where is it here, you check if it's a union, and if it's a union, you use the alias you declared before. Otherwise, you create an empty alias sequence. And you do this for all your individual, like for structs, for classes, for unions, for interfaces, and so on and so forth. And then like in the end, you basically instantiate the selected statement over there and basically have a ternary type selection thing built. And this is readable, right? I mean, even if you can't see it from back there, this looks noisy and weird, and this looks just, oh, nice and easy and straight line, and you don't really have to think about much. And I'm really running out of time. And now we are coming to the exploding in my face part. Currently, I have sort of a project with 7,000 lines, and I have to wait 8 seconds for that. And this is exactly for the reason Stefan mentioned, because static for each everywhere, and I have like 50-ish types, and this just gets out of hand very quickly. And yeah, we're going to skip that. And I'm out of slides. Thank you.
All right, so now it's questions time. Raise your hand if you got one.
If you got a hand?
Well, hand and question. If you don't have a hand, do something. There's one over there, Mike.
Could you make the resolver codes like as functions inside the structures and then annotate them with a UDA?
Yes, you could. Yeah, I mean, there's not much stopping you, right? Yeah. If you have the backend, if you have an instance from that, creating a delegate from the function, yeah. I just found this easier, and the cool part about doing it this way is you can actually sort of stack your delegates into each other. Then sort of the first thing is the request, are you actually allowed for this endpoint? So you can do your authentication there, and then you can do the extraction there and sort of do proper error handling in that thing, and then delegate that forward to the actual implementation of getting the data out. And there's technically nothing stopping you on doing this sort of as member functions, but I just found this to be more readable. And then actually doing generation of the TypeScript classes is easier because you don't have to filter so many fields. But yeah.
All right, any other questions?
Everybody's asleep, awesome.
Yeah, that's that food coma I told people to avoid. All right, well, I guess we're done here then. Another round of applause for Robert.